Okay, so here's a completed table for question number 9. Take a minute and check it out to see how yours compares. Hopefully everything lines up. If we look at row 3 here, we can see 3 to the power of 5. The base is 3, the exponent is 5, and that is the same as 3 times 3 times 3 times 3 times 3, or 3 times itself 5 times. And if we evaluate that, we get 243. On to question 10. This one's a little bit different. So if we look at the first expression here, we have a negative 2 to the power of 3, or the negative of 2 to the power of 3. So the power is really just 2 to the power of 3. So the base is 2, the exponent is 3, and there's still that negative in front. So we can write that as a negative 1 times 2 times 2 times 2, or as the negative of 2 times 2 times 2. Either way, we get negative 8. If you compare that to the second one, you can see how the negative 2 is inside brackets with the 3 or the exponent directly on the outside. So the power of 3 is raising or multiplying everything inside the brackets. So negative 2 times itself 3 times. Negative 2 times negative 2 times negative 2. So our base is negative 2, our exponent is 3, and we also get negative 8 here. On row 3, we have the negative of 2 to the power of 3, so that's much like the first row. And below, on the fourth row, we have negative 2 to the power of 3 all inside brackets. So these brackets have nothing going on the outside of them, so they're totally irrelevant. And that makes row 4 just the same as row 1. Adding a couple little pieces here. A number that multiplies a variable is called a coefficient. So if we're multiplying these powers or any type of variable, the value in front for here, for example here, 7p cubed, the 7 is the coefficient. And if we were to write 7p cubed out in expanded form or repeated multiplication, we would have 7 times p cubed, which is p times p times p. And if we were to compare that to 7p cubed, we can see that here 7p is inside brackets. So all of that is being cubed, which gives us 7p times 7p times 7p. So common pieces or similar pieces, they both do have a coefficient of 7 in there somewhere. They both have an exponent of 3, but the base is different. The base for 7p to the power of 3 is just p, and the base for this 7p all to the power of 3 is 7p. And when we multiply those out and rearrange them a little bit, it looks quite different. So hopefully you can see those differences and make sure that you use them as you move throughout this unit. And you can dive into your practice questions. Good luck.